Hello guys, my name is Vanny and my research was about carbon monoxide.
So, for the beginning, what is carbon monoxide? So, carbon monoxide is, from the chemical or the chemistry point of view, it is a triple bond that is created between carbon atom and oxygen atom, and this produces carbon monoxide. Carbon monoxide is a colorless gas, which is considered to be simple but complex gas. It is causing nausea, vomiting, and death if it's consumed in big amounts. Carbon monoxide is also called a silent killer because it is invisible. There are many sources that we can inhale carbon monoxide from, but the most famous or most popular carbon monoxide source is from car emissions and from inhalation of fumes as well. Another source is carbon-containing fossil fuels, which include wood and charcoal, which is familiar to us. So, when the carbon dioxide enters the body, it generates carboxyhemoglobin, and this disrupts or unbalances oxygen transport from the lungs to our tissues.
So the pathway of carbon monoxide starts with generation of carboxyhemoglobin, which cuts oxygen flow from the lungs to the tissues. When the carbon monoxide is inhaled by us people, it diffuses over the alveolar membrane, which is in our lungs, as easy as oxygen. So when we breathe oxygen in, it's basically as easy process as breathing in carbon monoxide. So the first step is that carbon monoxide is released in our bodies and it gets in our system through the bloodstream, which binds to hemoglobin. Carbon monoxide has a strong bond with hemoglobin, which is statistically speaking around 200 times greater than oxygen. Tissue hypoxia will be result when oxygen delivered blood is going to get lowered compared to carbon monoxide. There are some people in this world that are exposed to carbon monoxide on a daily basis. For example, workers who work in combustion engines, or drivers, police officers, workers who work in tunnels or chemical industries, firefighters. They're all at high risk of carbon monoxide poisoning or carbon monoxide exposure. And high amount of tobacco smoke increases personal exposure to carbon monoxide, as well as increases the exposure to other people who are around smokers. To be more specific about carbon monoxide pathway, this picture that is attached on this presentation is going to help you follow up more in details, step by step, the pathway of carbon monoxide. So carbon monoxide is produced through HO dependent and independent pathway. So the first produced carbon dioxide, as you can see, is the biliverdin and iron, and then there is a second that is just carbon monoxide as a standalone product. When we increase the formation of the reactive oxygen species, it can influence and affect the vasodilation or vasodilatory pathways, which can be associated with the carbon monoxide mediated vasoconstriction as listed on the bottom of the picture in green and red. There was an experiment on rats where they were looking at the effects of antioxidants and how they were conducted in both the presence and the absence of antioxidants, which is also shown in this scheme where there is antioxidant activity. And the real carbon monoxide was constricting renal arteries in our body, and it was boosting oxygen generation in the kidneys. In this research, it was discovered that the antioxidants are inhibiting the carbon monoxide-induced oxygen production, and it changes the carbon monoxide role from being constrictor to being dilatant. So this means that by presence or absence of certain things, the carbon monoxide can be either really harmful or beneficial. So when carbon monoxide is present, the complex 4, which is a part of the mitochondrial electron chain, and also certain enzymes, which I'm not going to name, but there are certain enzymes which work together and they create oxygen as a part of the chain reaction. And the inhibition of these enzymes can change the function of carbon monoxide, which is going to change from the constrictor role to dilatant role. I hope I'm pronouncing it correctly. The vasodilation and vasoconstriction activities, we can call them activities, are both dependent on heme oxidase, which is HO, and independent in generating the carbon monoxide. So with the production of this toxin, carbon monoxide, by heme, as we can see the top object, metabolism occurs in the presence of equal amounts of the biliverdin and iron. I don't know how to pronounce the biliverdin word, but it's the one on the right in the green. So carbon monoxide doesn't have to be, but may be produced by other causes than the heme metabolism, but this is like the main one. There is other ones that include organic molecule oxidation and, as I am pretty sure, membrane lipid pair oxidation. So the carbon monoxide has an impact on the microcirculation, and it also has a impact on the vasodilatory effect on the liver. There is an example of exogenous carbon monoxide, which was shown to widen the coronary arteries in rats, and it was this exogenous carbon monoxide kind of showed the same effects and the same work to nitric oxide, which works by activating the soluble guanylate cyclase enzyme. There is detrimental consequence of smoking, and the long-term effects of smoking on smokers' carbon monoxide levels are unknown, but there is definitely bad effects of smoking. Certain things that we have in our homes that produce carbon monoxide is, for example, gas burners. If there is insufficient airflow into the burners, there is burn-on corrosion on the burners, and air is flowing directly into the burners, not out. And there is a lot of gas pressure buildup, and this poorly adjusted burner air shutters causes increase of carbon monoxide production from these burners that we own and have around us in our homes. Another example is wood burning, like for example open fireplace or bonfires, is always resulting in high levels of carbon monoxide that are being released into the air and the atmosphere. There's ways for us to pretend the emission of combustion products into the restricted spaces like our homes, and the catalytic converters and non-catalytic converters, gasoline engines, they emit large levels of carbon monoxide from the start. And that is a really good way how we can prevent ourselves from inhaling so many toxins, including carbon monoxide, in our homes where we spend every day, where we sleep, where we eat, where we just live. It should not be dangerous for us to breathe the air in our home.